In the last section, we finished up going through the 5 different steps that occur during one tick of the event loop. In this section, we're now going to move on and start talking about some very interesting things about the event loop. The first thing we're going to discuss is to clarify a very common misconception about Node. So here's the misconception. You may have read online from time to time that Node is single-threaded. That's what people claim. People say Node is single-threaded. I even showed you a diagram a few minutes ago that clearly declared that the event loop uses just one thread. However, that's not the full story. The truth is much more complicated. So in this section, we're going to start to investigate whether or not Node is truly single-threaded. All right, so here's kind of going to clarify what's going on here. We're going to investigate this claim a lot, but here's the first taste of it. So the Node event loop that we just went through is truly single-threaded. When we start up a program with Node, a single instance of the event loop is created and placed into one thread. Now that's commonly seen as kind of a bad thing because it means that our program can only run on one core of our CPU. So if we have many cores inside of our CPU on our computer, then Node is not going to automatically take advantage of those. So in other words, our program might not run as fast as it could be because it's limited to one single thread. However, some of the functions that are included inside of the standard library of Node are not actually single-threaded. In other words, some of the functions that are included inside of Node that we run outside of our event loop and outside of that single thread. So simply declaring that Node is single-threaded is not absolutely true. The event loop uses a single thread, but a lot of the code that you and I write does not actually execute inside that thread entirely. So in this video, we're going to start to look at a couple examples of that. Now, I'm not going to show you any diagrams, and I'm not going to give you any long speeches to convince you of how this works. Instead, you and I are going to write some code. We're going to then execute it at the command line, and you're going to get some very real proof that not all of Node is truly single-threaded. So let's open our code editor back up, and we're going to write a little bit of code. All right, inside my code editor, I'm going to create a new file, and I'll call it threads.js, like so. Inside this file, you and I are going to require in the pbkdf2 function. That's that hashing function that we looked at in the crypto module just a little bit ago. In particular, we're going to try to run that function, and we're going to benchmark exactly how long it takes to run on our computer. So let's first start off by requiring in crypto at the very top. And remember, this is a standard library that is included with Node. We're then going to pick off the pbkdf2 function and execute it inside this file. So I'll say crypto.pbkdf2, and then we're going to pass in a couple arguments here. Now, you don't really need to know exactly what this function is doing because I know I haven't really clearly told you what it's doing. All we're doing is using this function to kind of do some expensive work inside of a program. So it's going to take this function a while to run, and we'll be able to benchmark the amount of time that it takes to run and use that to detect whether or not Node truly is single-threaded. So I'm not going to tell you too much about the arguments here. We're just going to throw the arguments in and move on. So as the first argument, I'm going to pass in a string of A. For the second, I'll pass in a string of B. For the third argument, and this one actually is important, so for this argument, please make sure you do the same thing as I'm going to put in 100,000, like so. So make sure you've got 100,000 exactly. Then as the fourth argument, I'll put in 512. For the fifth, I'll put in a string of SHA-512. And then as the last argument, I'm going to provide a callback function. Now the callback function right here gets invoked after the pbkdf2 function has successfully executed. So this function takes quite a while to run. In total, on my machine, it's probably going to take about 1 second to run. And to handle that duration or that amount of time that it takes to execute, we get this callback function that gets called after this hash has been successfully computed. Again, we don't really need to know what the function itself does. Basically, we call the function, and then eventually the callback is going to be executed. Okay, so let's take a quick pause right here. When we come back in the next section, we're going to add in a little bit of code to benchmark how long it takes this thing to run. So quick break, and I'll see you in just a minute.